Okay, in section 3.3, we're just going to do a little review. So we just talked about polynomials, graphing them, etc. But sometimes we encounter a problem where we actually need to do a division of two polynomials. So this section 3.3, it's just a little review section since some of you may have forgotten how to actually do long division of polynomials. So I'm just going to do a few examples just looking at that process. So this will be a shorter section. So let's see, divide p of x is 4x squared minus 3x minus 7 by q of x is 2x minus 1. So the first thing I do is just set that up as a long division. Okay, then here's what I'm going to do next. I'm going to say, what happens if I divide the lead term inside by the lead term outside? So I'm finding what is 4x squared divided by 2x. It's 2x, right? So that goes here. That's step one. Now I take that term and I multiply it down by both terms in the divisor. So that's going to give me, let's see, I'll have 4x squared minus 2x. Then I subtract that whole quantity. Okay, 4x squared minus 4x squared cancels. That's why this process works, because I'm always able to cancel out that lead term. Don't forget to distribute the negative here. So what I actually have is negative 3x plus 2x. Negative x. Okay, then I start the process again. So now I say, okay, I'm going to take that lead term there and divide by the lead term in the divisor. So what is that, negative a half? Okay. Let's go ahead and bring this down as well. Okay, now I'm repeating the same step. So now I'm going to multiply this by both terms in the divisor. It's going to be negative x plus a half, subtract this quantity. Okay, so negative and negative is positive, negative x plus x cancels, right? That's always the case. So then what do I have there? I have negative 7 minus a half. So what is that? Negative 14 halves minus 1 half? Negative 15 halves. Okay, then I would repeat the process. I'd say, okay, well, I'm going to divide this by that. But I can no longer divide, right? Because this guy here has a higher degree than this guy here. So actually that means I'm done. So then I just have to kind of write out, well, what the heck does all of this mean? So when I can no longer divide, this guy's called the remainder. All right, so how would I write this out? So if I wanted to actually write out my division, I'd say 4x squared minus 3x minus 7 divided by 2x minus 1 is equal to my quotient. That's what I got when I did the division. And then I have my remainder. Now that remainder was not actually able to be divided by the divisor, okay? So it has to stay over that divisor. Okay, so what can well, I don't know if I need to write much. Again, let's see. This guy, it's called the remainder. This is called the quotient. This is called the divisor. Okay. Okay, let's look at a couple more. So what about number 2? Dividing, again, p of x by q of x. So what I did here is I went ahead and set up the long division. So I'll start with 2x to the 4th divided by x squared. 2x squared. Multiply that down. 2x to the 4th minus, I want to make sure these line up. Let's see. Plus 8x squared. And go ahead and bring that x cubed down. Subtract. And then repeat. So negative x cubed divided by x squared. I want to use the black, negative x. Okay, so it's negative x cubed minus 4x. It's x squared plus 4x. And then x squared divided by x squared plus 1. Okay, and then we multiply that down. So x squared plus 4. Okay, and then when we try to repeat dividing 4x by x squared, it's no longer divisible. So that means we have our remainder. Okay, I was just cleaning this up a bit. Okay, so then this is the remainder. This is the quotient. Okay, and then let me just write out the division. Just gonna move this up a little bit. So let's see. So then I'm gonna have this guy. Divided by x squared plus 4, the quotient 2x squared minus x plus 1, and then the remainder has to stay over the divisor. Okay. And then I set up one more here. Okay, so let's give this a try. Okay, so 2x to the 5th divided by 4x squared, that'd be a half x cubed. Okay, multiply that down. Okay, so let's see, scratch work here. I have to do a half x cubed times 4x squared. That'd be 2x to the 5th. Okay, then I have to do a half x cubed times negative 6x. That'd be negative 3x to the 4th. Okay, and then a half times 8, 4x cubed. Subtract. Okay, 2x to the 5ths cancel. Negative 4x to the 4th minus 4x cubed. Bring down the rest here. And then I start over. So now I'm going to be taking the negative 4x to the 4th and dividing by 4x squared. Okay, so that's going to be minus x squared. Okay, then I multiply that down. Okay, so let's see. Negative x squared times 4x squared, negative 4x to the 4th. Negative and negative is positive 6x cubed. And then minus 8x squared. Okay, so what do we get here? Negative 10x cubed plus 8x squared. Bring this down. Okay, and then I start over. Okay, I've got negative 10 x cubed over 4x squared 5 over 2x. Okay, multiply that down. Some more scratch work. Let's see, so that's we have negative 5/2 x times 4x squared. That's negative 10x cubed. And then we have negative 5/2 x times negative 6x. That's 3 times 5, 15x squared. And then we have negative 5/2 x times 8. That's negative 20x. so negative 7x squared plus 20x minus 13. And then one more time, looks like. As now I've got to do negative 7x squared divided by 4x squared. Negative 7 over 4. Okay. Distribute. So that's negative 7x squared. Let's see, negative 7/4 times negative 6. 6 divided by 4. Let's see, that'd be 3 over 2 times 7. That's 21 over 2. And then negative 7/4 times 8, negative 14. Almost there. Okay, then what is 20 minus 21 halves? I guess that'd be 40 halves minus 21 halves, 19 halves. And then positive 14 minus 13, 1. Okay. And then looks like have my remainder. So then I just have to write out this division. All right, so how would that look? Let's see, I have 2x to the 5th minus 7x to the 4th minus 13 divided by 4x squared minus 6x plus 8. And the result was a half x cubed minus x squared minus 5 halves x minus 7/4. The remainder was 19 halves x plus 1. That has to stay over the divisor. And there